Good day, students. Welcome to mathcodeserver.com. In this clip, we're going to be going over part 3 of our Unit 1 Algebra 2 Common Core test review. All right, let's take a look at question number 1. It reads, a point on the graph y equals f of x is 3, negative 5. State what this point will become in the graph of y equals negative f of x. So this is a transformation right here, y equals negative f of x. What kind of transformation is this? Well, there are two ways we can do this. We can do this algebraically or graphically. Okay, if we want to do this algebraically, what we'll do is examine the transformation y equals negative f of x. What is happening here is y is becoming the opposite of what it was in f of x. This minus indicates opposite. Okay, so if the original function is 3, negative 5, then this transformation is going to simply negate just the y-axis. Okay, that's what's going to be negated there. So negative f of x is going to become 3, comma, the y-axis becomes the opposite of what it was in the original one. So negative of negative 5. All right, and then if you simplify that, your answer is you're going to have negative f of x. It's going to have the point 3, comma, positive 5. Okay, so this negative f of x just simply switches the sign of the y coordinates. Now, this is how to do it algebraically. If you want to do the same problem graphically, all you simply do is you draw the graph of the object, which is 3, 5, 3, negative 5, so 1, 2, 1, 2, 3, and then go down 1, 2, 3, 4, 5, right there. So what kind of graphical transformation is negative f of x? Negative f of x, in this case, a is less than 0. Anytime you have a less than 0 or negative f of x, you're going to reflect in what direction? You're going to reflect vertically across the x-axis. Okay, so all we'll do is reflect this point vertically across the x-axis. Since this is 5 units down, we'll simply go the same number of units in the opposite direction from the x-axis, 1, 2, 3, 4, 5, and there goes your negative f of x. So what are the coordinates of this point? 1, 2, 3, 1, 2, 3, 4, 5, 3, 5. There goes your final answer. So you can solve this problem algebraically by simply taking the opposite of the y-axis, the y-coordinate, or you can graph the point and carry out the transformation, which is a reflection, to determine the resulting coordinate, which is 3, 5. So whichever method you want, you will get full credit. All right, let's take a look at number 2. For number 2, it reads, the graph of y equals f of x is shifted 4 units right, 5 units up, and reflected in the x-axis. The equation of the transformation is, so we're going to break this into the different parts. Let's take a look at the first translation. The first transformation is 4 units right. So what effect does that have on the y equals f of x? 4 units right is going to be f of x. Now, when you're dealing with the horizontal translations, horizontal shifts, it's opposite. Okay, so going to the right is going to be minus 4. Okay, so f of x minus 4. That is the shift to the right. Now 5 units up, what is that? It's going to be the function. Up is plus 5. When you're shifting vertically, you simply follow the direction of the number. Up is positive, down is negative. Now, and then it's reflected in the x-axis. Now, what kind of transformation is that? Reflection in the x-axis is a vertical reflection, That simply means that a is going to be negative, so that will be negative f of x, just like the example we did in number 1. Okay, so if we combine all this together, the resulting function is going to be y equals a is negative negative f of x minus 4 for the shift 4 units to the right, and then k is going to be plus 5 for the shift 5 units up. There goes your final answer. All right, let's take a look at problem 3, the A part. It reads, describe the sequence of transformations used to graph the functions, then graph the function. So here we are going to, let's look at the A part. We have a quadratic, a parabola. This 2 basically means that we have a dilation, okay? So we have a dilation. What kind of dilation is that? Is a stretch by a factor of 2 vertically, up and down, okay? A vertical stretch by a factor of 2, then plus 2 and minus 4 are shifts. So what are our shifts? We have 2 units to the left for x plus 2 and 4 units down for minus 4. Okay, so we can go ahead and sketch the graph. We're going to, let's draw our original. The original, something like this. It's just a rough sketch. Alright, so we have our original parabola looking something like this. And what we're going to do is we're going to carry out some transformations here. The first transformation is a stretch by a factor of 2. Now, if we stretch this graph by a factor of 2, what happens? It basically becomes narrower, so it looks something like this. If we stretch it, it just becomes narrower. Now, we're going to shift it 2 units to the left, 1, 2, and then 4 units down, 1, 2, 3, 4. Okay, so our final parabola will look like something like this. Just a rough sketch, something slightly skinnier. Okay, so that's basically the sketch for what this resulting parabola will look like. All right, let's take a look at the second one, B. We have a negative sign here. That's a reflection. What kind of reflection is that? Since A is negative, we're going to reflect vertically across the x-axis. Minus 3 and minus 1 are shifts. So what are our shifts? We have negative 3 means you're shifting 3 units to the right, and then minus 1 means you're shifting 1 unit down. Okay, so originally we have your typical absolute value function, something like that. And then we're going to reflect it downwards. When you reflect it downwards, it goes down like this, just like your v function. And then we're going to shift it 3 units to the right, 1, 2, 3, and 1 unit down right here. And then we'll have our final absolute value function, which is something like this, and then like that. Okay, let me move this point a little bit. Okay, so there goes your absolute value function right there. All right, let's take a look at question number 4. It reads, the parent function f of x equals 2 to the x is vertically stretched by a factor of 4, translated left by 4, and translated 2 units down. Write the new function. All right, so let's take a look at the transformations one by one. Let's look at the dilation first. It's a vertical stretch by a factor of 4, so we're going to have y equals 4 times the function. A translation, 4 units to the left, so that's going to be y equals f of x So to the left is plus 4. You just add x to the 4 to the x in the parentheses, and then translate it 2 units down. That's going to be the function as a whole minus 2. Okay? Now if we assemble everything together, we're going to have the function y equals, now the function is 2 to the x, right? But we have to have a 4 first for the vertical stretch. 4 times the function, which is 2. But for the x, we need to replace the x with x plus 4. So 2 to the x plus 4. For k, we need to subtract 2 from the entire function, so subtract 2, subtracted by 2. And there goes your function. All right, let's take a look at question number 5. Question 5 reads, write the equation for the graph shown at the right. So we have the assumption is that we're dealing with the parent function, y equals the absolute value of x, which is expected with the graph that we have here. So if you take a look at this absolute value graph, one thing you notice is that this graph has been dilated. Ideally, if we were to graph the original function, after reflection, it should go through this point and that point in that pattern right here. But instead of going through that point, it goes through half the distance. So it's going through half. So since it has been shrunk by half, we have a dilation, which is a vertical compression by a factor of 1/2. Okay, so let's write that down. We have a vertical compression by 1/2, and that simply means that we're going to have y equals 1/2 of the function. Okay, now let's look at the reflection. Since this absolute value function opens downwards, what does that mean? It means it has been reflected vertically. Okay, so it has been reflected down or vertically across the x-axis, and what does this mean? It means we have y equals negative f of x. Negative f of x means a reflection vertically. Okay, now the coordinates of the vertex can tell us what the shifts are. The coordinates of the vertex is 3 and 2. This means the graph has been shifted 3 units to the right and 2 units up, because the original point of the vertex was 0, 0. So it achieved this vertex by shifting 3 units to the right and 2 units up. Okay, so the graph was shifted 3 units to the right and 2 units up. So what does that mean? We have y equals the function x plus, to the right 3 units is actually the reverse, x minus 3, and then 2 units up is plus 4. Okay, so we're going to assemble all this information into this function right here. The function is the absolute value function. So our result will be y equals, what are we multiplying the function by? 1/2 times the absolute value of x. We are subtracting 3 from the x because we have a 3 units shift to the right. And then we're going to add, I don't know why that's a 4, that should be 2, because we're going up 2 units, right? So sorry about that. This is 2 plus 2. Okay, so this is the graph of the function, and also we don't want to forget the reflection. We have a reflection there, this minus, so we just put a minus here to indicate that the graph is actually opening downwards. So there goes your final result.